Hi everyone, we're Mimicker, here to introduce all kinds of knowledge, even stuff we didn't know about, and welcome to the Deep Dive, your shortcut to being truly well-informed, without all the information overload. Today we're embarking on a really fascinating journey. We're going into a concept that's, well, as ancient as philosophy itself, yet it turns out it's profoundly relevant for cutting-edge innovation today. We're talking about first principles. Our source material for this deep dive comes from some really insightful excerpts from Gukic O. Moosh. Now that translates roughly to first principles, the fundamental thinking of innovation. And our mission today is pretty clear. We're going to unpack this incredibly powerful concept. We'll trace its origins, way back to ancient philosophy. Then we'll explore its really rigorous applications in modern science. We'll dissect its transformative impact in business and entrepreneurship. And ultimately, we want to reveal why this way of thinking is absolutely crucial for you in navigating today's complex, really fast-paced world. Now, you've likely heard this term bubbling up, especially in connection with some of the boldest innovators of our time. Yes, we are indeed talking about people like Elon Musk. But what is it about a concept that started with ancient Greek philosophers that makes it so vital, so revolutionary for driving modern breakthroughs? Get ready, because this is going to be a deep, deep dive. We're going into the very bedrock of how we truly think, how we create, and fundamentally, how we genuinely solve problems. Let's dig in. Okay, so let's unpack this right from the very beginning. Before we dive into all the fascinating, diverse applications, we really have to lay the groundwork. What exactly are first principles? When we talk about first principles, we're not just talking about going back to basics in some kind of superficial way. No, we're talking about getting down to the absolute, irreducible core of something. These are the most fundamental propositions or assumptions. Imagine trying to build a house. First principles aren't the walls or the roof. They're the very ground you build upon, that bedrock that cannot be moved or broken down any further. They're truths that cannot be deduced from anything else. They simply are. Think of them like axioms in mathematics. Those foundational self-evident truths you just accept without needing proof.
Right, because everything else is built on top of them.
Exactly. Every single theorem, every complex equation, every grand structure of mathematical knowledge, it's all built directly upon those axioms. And just like you can't violate an axiom and expect your math to hold up, you can't violate a first principle in your thinking and expect to arrive at truly sound or innovative conclusions.
And what's truly fascinating here, I think, is how deeply rooted this idea is. It stretches back not just decades or centuries, but literally thousands of years. This isn't some, fleeting Silicon Valley buzzword that just popped up. It's a profound concept that humanity's earliest and, greatest thinkers were grappling with. The very genesis of first principles thinking, it traces its origins back to the pre-Socratic Greek philosophers. These were people who, in many ways, were the first truly critical thinkers. We might even call them the first scientists of the Western world. And their overarching quest was, monumental. They wanted to find the origin of all things, what they termed arche.
Arche.
Yeah, arche. It's a Greek word, and it encapsulates this idea of a beginning, an origin, or even a ruling principle. These early thinkers were just driven by this insatiable curiosity to understand the fundamental substance or principle from which everything else in the universe derived. They wanted a single, unifying explanation for, the bewildering complexity of existence.
Wow. So they were really going for the big questions right from the start.
Oh, absolutely. Consider, for example, Thales of Miletus. He's often revered as the very first philosopher. He looked at the world around him, and with, frankly, remarkable observational power for his time, he boldly proposed that the arche, the ultimate source of everything, was water.
Water? Why water?
Well, his reasoning wasn't arbitrary. He observed that water was absolutely essential for life to flourish, right? He saw that it could readily change forms, liquid, solid ice, gaseous vapor, and it seemed to be present everywhere, shaping the land, filling the seas. So for Thales, water was the irreducible element. Everything emerged from it, everything returned to it. It was fluid, transformative, omnipresent. That was his fundamental principle.
Okay, I can see the logic there for his time.
Exactly. Then, following him, you had Anaximander, another brilliant pre-Socratic. And he took a different intellectual leap. He thoughtfully disagreed with identifying the arche with any specific finite element like water. His reasoning was, if one element gave rise to others, then logically there must be something even more fundamental, something unchangeable and truly boundless.
Boundless?
Yeah, because if the arche were a specific element, like water, then it too would need an origin. So he argued for the apeiron, which means the indefinite or boundless. He suggested the universe sprang from this infinite primordial mass that didn't have specific qualities itself, but could encompass all possibilities and give rise to all known elements.
That's quite abstract.
It is. Very philosophical. And then you have Anaximenes. He observed the vital role of breath, the way things change states, and he proposed that air was the fundamental element. He saw air as the essence of life, breathing, motion. He observed how it could condense into clouds, water, earth, or rarefy into fire. So he used air to explain the diversity of the world.
So water, the boundless, air, they didn't agree on the answer.
No, they didn't agree on the specific answer. But despite their diverse conclusions, these early thinkers all shared this common, ambitious, intellectual goal: to explain the vast complexity of the universe through a single, unifying, irreducible principle. They were quite literally trying to uncover the first principle of existence itself.
That's incredible. And then Aristotle came along.
Yes, centuries later. And it was Aristotle who truly systematized this profound inquiry. He formally called it the study of first principles in his seminal work, the Metaphysics. He wasn't just observing like the pre-Socratics. He was building a rigorous framework for how we acquire and structure knowledge. Aristotle argued quite passionately, actually, that every field of study, every system of thought, indeed every existing thing, is ultimately grounded in some basic starting point or principle. These principles, he asserted, are so fundamental that you cannot ignore them or eliminate them if you genuinely wish to understand the subject matter.
So you can't skip the foundations.
Exactly. For Aristotle, to truly know something wasn't just about observing or collecting facts, it was about understanding its root causes, its underlying principles. He famously stated, and this is a direct quote, "We think we know something only when we know its first causes and principles."
That hits deep.
It does. And this wasn't just some philosophical musing for him. He firmly believed that investigating these first principles was the absolute foundation of both philosophy and scientific knowledge. It formed the very bedrock upon which all other truths could be built and upon which all logical reasoning must stand. His work essentially cemented first principles as a cornerstone of rational inquiry in the West.
Wow. So this idea has been baked into Western thought for millennia.
Absolutely. This profound philosophical foundation, laid by the pre-Socratics and then systematized by Aristotle, deeply embedded the idea of first principles as a core concept throughout Western thought. It became inextricably linked with notions like the first cause, that concept debated in theology and cosmology, the uncaused cause of everything.
Right, the ultimate origin point.
Exactly. Or with the idea of self-evident axiomatic truths, which, as we touched upon earlier, serve as those unquestionable starting points in logic, math, even ethical reasoning. So whether you were a medieval scholastic philosopher trying to reconcile faith and reason, or an Enlightenment rationalist seeking to build knowledge on undeniable foundations, the idea was the same. You had to ground your reasoning in these fundamental, irreducible truths. That was paramount. It became the accepted, rigorous method for building robust arguments, constructing reliable knowledge, and pushing the boundaries of understanding. It really set the stage for what we now recognize as scientific inquiry.
Okay, so stepping back, what does this all mean for us today? It's not like going back to basics, but in a really profound, almost radical way. For you, the listener, this isn't just some historical curiosity, right?
Not at all.
This ancient insight isn't just about understanding what truth is, maybe. It's about cultivating I guess, the courage to strip away layers of accepted wisdom, to challenge conventional thinking, and to really dig for the bedrock of reality. It's about recognizing that seemingly overwhelming ideas or really entrenched problems can actually be made approachable, not just by breaking them into smaller pieces, but by asking that key question: what is the absolute, undeniable truth at the core of this?
Precisely. It's an invitation to develop a powerful conceptual toolkit.
Yeah, like tools for peeling back layers of complexity, refusing to accept something just because that's how it's always been done, and instead asking why repeatedly until you hit that irreducible foundation. That, I think, is the real transformative power of this ancient idea for us now. Okay, now, here's where it gets really interesting for me. This concept isn't just gathering dust in old philosophy books or university libraries. This idea, this rigorous method of reasoning from first principles, it's found a remarkably powerful and practical home in modern science, especially in fields like physics, chemistry, material science.
That's right. It's been transformed from this, abstract philosophical concept into a concrete, predictive, and often revolutionary methodology. It actually allows scientists to model and understand the universe at its most fundamental level.
So how did that work in practice? How does a scientist operate from first principles?
Well, in modern science, operating from first principles has a very specific and rigorously defined meaning. When scientists talk about first principles calculations, or maybe more formally, ab initio methods,
Ab initio.
Latin, yeah, Latin for from the beginning. When they use these terms, they're describing a process of deriving conclusions directly from fundamental natural laws. And crucially, without relying on any empirical models, historical data, or even common assumptions from the field.
Okay, wait. No empirical data. How?
It sounds counterintuitive to how we often think science works, right? Imagine building a complex structure. Most engineering might use blueprints based on past successes or data from stress tests. A first principles approach in science, though, starts not with those blueprints, but with the fundamental laws of physics that govern materials, forces, energy. It's about building understanding and making predictions from the absolute ground up, using only the most foundational, undeniable truths of the universe itself.
So what kind of truths are we talking about?
These methods are based solely on the core physical laws that govern our reality. Predominantly quantum mechanics, which describes how matter and energy behave at the atomic and subatomic levels. Researchers don't start with observations of how a material behaves in a lab. They don't fit their theories to experimental results they already have. Instead, they begin with the fundamental constants of nature, things like Planck's constant, the charge of an electron, and foundational equations. The big one is often the Schrödinger equation.
The Schrödinger equation. I've heard of that. Sounds complicated.
It is, mathematically. But conceptually, it describes how the quantum state of a physical system changes over time. It's incredibly powerful. By inputting only basic information like the atomic nuclei involved, their atomic number, their positions, and the number of electrons in the system, scientists can use these first principles calculations to predict all sorts of things: the structure, the properties, the behavior of materials or molecules.
All from just the basics.
All from just the basics. And the crucial distinction here, what makes these methods so uniquely powerful and fundamental, is that they do this without fitting to experimental data. They don't tweak their calculations to match what someone already saw in a lab. Instead, they predict what should be observed based purely on the fundamental immutable laws of physics.
So it's predictive, not just descriptive.
Exactly. It's about deriving truth, not merely observing or explaining truth that's already known.
Can you give us a concrete example? It's still a bit abstract.
Absolutely. Well, let's make this concrete with a specific and widely used example from computational chemistry. Density functional theory, usually called DFT. DFT.
Okay.
Using DFT, scientists can model the behavior of incredibly complex materials, think superconductors or biological molecules, catalysts, starting from something remarkably basic. They start with just the atomic numbers of the elements involved.
Just the atomic numbers, like carbon is 6, oxygen is 8. That's it.
That's essentially the starting point. You're literally starting with just the number of protons in an atom, which fundamentally defines the element and its electron count. From that absolutely fundamental information, combined with the rigorous laws of quantum mechanics encoded in DFT, they can then derive incredibly complex and specific properties.
Like what?
For instance, they can predict the electronic structures of these materials. That dictates how they conduct electricity, how they absorb light, how they interact with magnetic fields, or how they'll react chemically with other substances. They can also predict ground state properties, like the most stable arrangement of atoms in a crystal, or the energy needed to break a specific chemical bond, or even the theoretical strength of a brand new alloy that's never been made before.
Wow. So they can design materials on a computer before making them.
Precisely. This approach, because it's entirely independent of prior empirical input and relies solely on universal physical laws, is considered one of the most rigorous, predictive, and truly foundational methods in all of science. It's really about creating knowledge and understanding from the most fundamental components of reality. It allows for the design of new materials, the prediction of new phenomena, sometimes years before they can be synthesized or observed in the lab.
Okay, that's actually mind-blowing. So it really is about building from the absolute ground up, using only the deepest truths of the universe, not just tweaking what already exists or trying to make sense of observations after the fact. That's a huge difference.
It is a fundamental difference in approach.
It's not about curve-fitting data you already have. It's about predicting the curve itself based on those foundational laws. And the insight for you, the listener here, is maybe that what science shows us is that first principles empower you not just to understand what is, but to accurately predict what could be.
Yes, by starting from the universe's most fundamental, unchanging laws.
It highlights the incredible power of this approach. for truly understanding foundational truths, and then using that understanding to innovate, to design entirely new materials, or even anticipate things nobody has seen before.
All based on principles considered universal and unchanging.
It's really a testament to the idea that true mastery comes from building from the very deepest understanding, not just surface observation. Okay, now let's make what feels like an incredible leap. We've seen how this ancient philosophical concept underpins the most rigorous parts of modern science. But what happens when we take this powerful fundamental way of thinking and apply it to the often, let's face it, messy, unpredictable, and rapidly evolving world of business and entrepreneurship?
Ah, yes. This is where first principles thinking truly explodes into the realm of practical innovation.
It often leads to profoundly disruptive ideas that completely change industries and challenge really deeply ingrained assumptions.
The question becomes, can that same rigor applied to quantum particles actually translate into effective strategic business thinking?
Yeah, does it work outside the lab?
It does, and it raises a fascinating and important question. How does a philosophical and scientific concept translate so effectively? In the realm of business strategy and entrepreneurial innovation, the first principles approach becomes an incredibly potent tool for radical reinvention. Applying it in a business context means stepping away from just making incremental improvements or simply copying what competitors are doing or following what the market seems to dictate or just adhering to industry best practices.
So not just doing things slightly better.
Not just slightly better. Instead, it compels you to think from the absolute ground up. You're forced to identify the most fundamental customer needs you're trying to satisfy and to define the absolute core value you are striving to deliver. It means challenging every single assumption about how things are done in your industry, no matter how established or, frankly, sacred those practices might seem.
Like questioning everything.
Pretty much. Rather than just accepting the status quo like, customers always pay X price for Y product, or this manufacturing process takes Z long because it always has, or we only sell through these channels because that's the industry norm. You have to ask different questions. You're compelled to ask. What is the absolute fundamental need here? And what is the simplest, most efficient, and most effective way to meet that need, assuming no prior constraints, no historical baggage, no existing models? This often uncovers paths that conventional thinking, which is constrained by those assumptions, simply misses entirely.
Okay, let's make that real. Can you give an example?
A fantastic illustrative example of this in action is Jonah Peretti, the visionary founder of BuzzFeed.
Ah, BuzzFeed.
Before BuzzFeed, think about the online content landscape. It was largely dominated by established editorial values, right? Quality journalism, well-researched articles, long-form pieces, entertainment structured like traditional print or TV. Websites were basically digital newspapers or magazines.
Yeah, I remember that.
Peretti, however, applied a first principles lens to this problem of online content in a rapidly evolving internet. He didn't just try to make a better online newspaper or a slicker digital magazine. He asked, what is the absolute fundamental value or maybe the function of content in a networked social world? And he identified shareability as the core principle.
Shareability, not quality, not length, but shareability.
Exactly. He realized that in an increasingly interconnected digital landscape where social media was just exploding, the fundamental value of content wasn't just its intrinsic information or entertainment value in isolation. Critically, it was its ability to be easily shared, discussed, and spread rapidly across social networks. That was the key function in that new context.
That makes so much sense in retrospect.
Right. This insight completely upended traditional editorial values, which often focused on things like authoritative reporting or literary merit. He replaced them with viral engagement strategies, optimizing for clicks, likes, shares, comments. He recognized these were the true drivers of reach and impact in the new digital ecosystem. This radical shift, based on a first principles understanding of online human behavior and the new mechanics of digital distribution, it ushered in a whole new era of digital media. It proved that sometimes the how things have always been done needs to be completely rethought. By going back to the very basic function content needs to fulfill in that specific connected world.
That's a brilliant example. He didn't just optimize the old model. He identified a new fundamental principle for a new environment.
Precisely. And we can look beyond the digital realm, too. Consider a company like Patagonia, the outdoor gear and apparel company.
Okay, so yeah, known for sustainability.
Exactly. Their entire business model, you could argue, is built on first principles of sustainability and durability. And this fundamentally redefines value in their industry. Instead of just participating in the fast fashion cycle, which prioritizes low cost, rapid consumption based on fleeting trends, Patagonia asked different questions. They asked, what is the fundamental purpose of clothing and gear, especially for outdoor enthusiasts? And what is our responsibility as a manufacturer?
Deeper questions than just, how do we sell more jackets this season?
Much deeper. And their answer, derived from these first principles, wasn't just to make functional products. It was to make products that last as long as possible, are repairable, and have the absolute minimum environmental impact throughout their entire life cycle. They don't just sell you a jacket, they offer lifetime repairs. They even buy back used gear to recycle or resell.
Which is pretty unusual.
Very unusual. Their prices are often higher than competitors, yes, but their customers are buying into a fundamentally different value proposition: quality, longevity, ethical production, environmental stewardship. This is a first principles approach because they stripped away the assumptions of mass consumerism and planned obsolescence. Instead, they focused on inherent needs for durability and environmental responsibility as the core drivers of their product design and their business strategy. They aren't really competing on price or trend cycles in the same way. They're competing on fundamental principles of utility and responsibility.
That's another great example of questioning the core assumptions of an industry.
And one more, in a totally different sector: education. Think about Sal Khan, the founder of Khan Academy.
Khan Academy, yeah, my kids use that.
Right. Traditional education systems are often built on a set of assumptions, right? Learning happens in a classroom, at a fixed pace for everyone, with a teacher lecturing to a group. Assessment happens at the end of a unit, maybe a test. Khan, approaching education from first principles, asked, what is the fundamental truth about how humans learn effectively? He identified that true learning, real understanding, requires mastery of foundational concepts before you move on. If you don't really get fractions, you're going to struggle with algebra no matter how good the algebra teacher is. If you miss a couple of lectures, you fall behind.
The mastery learning idea.
Exactly. His first principle was mastery learning. So he built a platform where students could learn at their own pace, revisit concepts as many times as they needed, practice until they got it, and only move forward once they've demonstrated complete understanding. He didn't just digitize textbooks or put lectures online. He deconstructed the learning process to its core components: individual comprehension, practice, feedback, mastery, and then rebuilt the educational experience from that fundamental insight. And this approach has radically changed how millions of people around the world learn, challenging centuries of educational conventions by returning to the core principle of effective human cognition.
Wow. Peretti, Patagonia, Khan. These examples are fantastic because they really showcase innovators looking beyond the obvious, beyond the established norms, to what truly drives value or solves a fundamental problem in a totally new way. Peretti didn't just make a slightly better magazine. He redefined what online content was for that era. Patagonia didn't just make clothes. They redefined responsible commerce in their sector. Khan Academy didn't just digitize lessons. They redefined the mechanics of learning itself. And speaking of driving innovation and redefining entire industries, there's one name that comes up constantly when we talk about first principles, especially in the context of these audacious, seemingly impossible goals.
Indeed. You can't really talk about first principles in the modern context without talking about Elon Musk. He has really brought this concept into the mainstream consciousness. He articulates it repeatedly, and he shows its application in ways that, frankly, many people find almost unbelievable. His direct and sometimes blunt application of first principles thinking offers incredible insights into how truly radical innovation can actually happen.
So what's his take on it? How does he define it?
Well, Musk frequently emphasizes that this mindset is the absolute key to solving complex problems and driving innovation. He often contrasts it directly with what he calls reasoning by analogy. He once famously said, and I think this quote captures it perfectly, "I tend to approach things from a physics framework. Physics teaches you to reason from first principles rather than by analogy."
Reasoning by analogy, meaning just copying what others do.
Essentially, yes, or just making small tweaks based on past examples. His critique of conventional thinking is quite sharp. He believes most people are bound by convention and rarely question the absolute essence of a problem. They reason by analogy. They look at how others have solved similar problems in the past, or how an industry has always operated, and then they simply try to adapt or incrementally improve those existing solutions. This, for Musk, is mental inertia. It's a resistance to fundamental questioning that acts as a huge barrier to true innovation and breakthrough.
Mental inertia, I like that term.
Yeah. He elaborates on his definition. First principles thinking means boiling things down to the most fundamental truths and reasoning up from there. It's not just a slight adjustment to an existing idea. It's about stripping away every assumption, every historical constraint, every traditional approach, until you're left with only the undeniable, irreducible facts, the physics of the situation, so to speak.
Okay, so boil it down to the physics.
Pretty much. And he acknowledges this process is far more mentally taxing. It's cognitively demanding. It's harder work than just using existing models or adapting old solutions. But he firmly believes it is absolutely essential for reaching truly novel and breakthrough solutions that can redefine what's even considered possible.
Okay, let's get into the famous examples. Tesla and battery costs. That's a big one.
It's a classic. For decades, the automotive industry and the battery manufacturing sector, they largely operated under this accepted belief that battery prices just couldn't drop significantly below a certain threshold, maybe $600 per kilowatt hour or something like that. It was just an industry truth, a convention based on decades of manufacturing practices and existing supply chains.
Everyone just accepted it.
Pretty much. But Musk didn't. He applied his first principles analysis. Instead of looking at the market price of batteries and trying to optimize production within those existing frameworks, he asked a fundamentally different question. He asked, what are the constituent materials of a battery? What are the raw elements? The nickel, the cobalt, the aluminum, the carbon, the steel casing, and how much do they actually cost on the commodities market? Like if I bought them on the London Metal Exchange.
He broke it down to the raw ingredients.
Literally, down to the atomic and component level. By summing up the raw material costs and considering the basic energy required for assembly, he arrived at a theoretical conclusion. He figured out that a battery, based purely on its fundamental material components, should cost dramatically less. His target was around $80 per kilowatt hour.
$80 compared to $600.
Exactly. A figure that was just way, way below the prevailing market prices at the time. And this radical insight, born from first principles, didn't just make him think about finding slightly cheaper suppliers. It fundamentally reshaped his entire strategy. It drove him and his team at Tesla to develop entirely new, radical cost-cutting innovations in battery design and manufacturing processes. Things like the whole gigafactory concept, where they integrated materials processing and battery production on an unprecedented scale, vertically integrating everything. All of that effort was aimed at bridging that huge gap between the theoretical first principles cost and the market reality. He essentially redefined what was considered possible in battery manufacturing by going back to the raw material costs.
That's incredible.
Yeah.
It wasn't about optimizing the existing system. It was about building a new system based on the fundamental cost limit.
Precisely. And he applied a very similar groundbreaking approach to rocket construction at SpaceX. This has had just a profound impact on the entire space industry, as you know.
Yeah, making space travel cheaper.
Dramatically cheaper.
Yeah.
For decades, space travel was incredibly expensive, primarily due to the single-use nature of rockets and the, well, complex, often bureaucratic, and highly inefficient traditional workflows of the legacy aerospace companies.
Cost plus contracts and all that.
Exactly. Again, instead of accepting that rockets are just inherently expensive to build and launch, Musk used first principles. He broke down the problem of launching payloads into space to its most fundamental elements. What is a rocket at its absolute core? It's primarily a structure made of specific metals, alloys. It has propulsion systems, fuel, oxidizer, electronics, guider systems. What is the fundamental cost of these materials? How much energy, according to physics, is fundamentally needed to put a certain mass into orbit?
Back to the physics again.
Back to the physics. He identified staggering inefficiencies in the traditional workflows, things like outsourcing almost every component, custom building every single part, adhering to decades of established, often massively over-engineered processes and standards. By questioning every single assumption and focusing relentlessly on the core physics and engineering principles, he championed innovations that the industry had dismissed. Most famously, reusable rockets, a concept long considered impractical or too difficult. And also, radical vertical integration in manufacturing, where SpaceX produces almost all its major components in-house, controlling the process and costs.
Which was totally different from how Boeing or Lockheed worked.
Completely different. And the result? He managed to cut launch costs at SpaceX down to just a fraction, maybe a tenth, of what competitors, the legacy aerospace companies, government agencies were charging for similar payload capacities.
A tenth. That's not improvement, that's disruption.
It's total disruption. It wasn't incremental improvement. It was a complete paradigm shift. And it was all born from stripping away those accumulated layers of how it's always been done and rebuilding from fundamental truths about physics, material science, and manufacturing efficiency.
And didn't he do something similar recently with a supercomputer project?
Ah, yes, the XAI Supercomputing Center. That's a more recent example, but it shows the same thinking. The challenge was that building a massive supercomputing center traditionally takes a long time, like 18 to 24 months, sometimes longer. Lots of specialized construction, complex power, and cooling infrastructure.
Right, a huge undertaking.
Musk, needing massive compute power for his AI ventures quickly, applied first principles thinking again. He deconstructed the problem into its essentials. What do you fundamentally need? You need buildings to house the servers, you need a massive reliable power supply, and you need extremely effective cooling systems to dissipate all the heat the chips generate.
Space, power, cooling. The basics.
The absolute basics. Instead of following the traditional lengthy construction playbook, he looked for unconventional, faster solutions for each component. Renting existing large facilities instead of building custom ones from scratch, bringing in large generators for immediate power instead of waiting for grid upgrades, using mobile, prefabricated cooling units instead of complex built-in systems.
Sort of hacking the process.
In a way, yes, by breaking it down and finding the fastest path for each fundamental requirement, ignoring the standard integrated approach. And the result was remarkable. They reportedly aimed to get the center operational in just 6 months.
6 months instead of 2 years.
That was the goal. A fraction of the traditional timeline achieved by questioning every step and focusing only on the core functional needs and the fastest way to meet them.
These examples are just genuinely inspiring. It really shows how incredibly powerful it is to just ignore the rules that the industry or conventional wisdom has maybe unconsciously established, and instead to go back relentlessly to what's truly essential and physically possible. It kind of challenges our very notion of what constraints truly are. Are they real physical limits or just accepted practices?
That's often the key distinction first principles helps you make.
And for you, the listener, these stories aren't just about rockets and batteries and AI or the incredible achievements of one particular visionary entrepreneur. They really feel like an invitation to consider the profound power of questioning assumptions in your own challenges, whatever they may be. Imagine if you approached a long-standing problem in your work, maybe a personal goal that feels completely insurmountable, or even a deeply ingrained habit you want to change. And instead of trying to find an existing solution out there to adapt, or just doing what you've always done, you asked, what are the absolute undeniable truths about this situation? What are its core, irreducible components? And what would a solution look like if I built it from that blank slate, ignoring how it's always been done?
It's a mentally demanding process, as Musk points out. It takes real effort to identify those true first principles and reason up from them.
Definitely harder than just Googling a solution.
Much harder. But the potential for breakthrough thinking, for real innovation in your own context, is immense.
Okay, so Musk uses this powerfully. But does he think everyone should think this way?
Yes, absolutely. This commitment to first principles isn't just about him using it in his companies. It's a mindset he deeply believes is essential for everyone, especially now in our current information landscape. He promotes it not just as an engineering tool, but as a general mode of thinking that really transcends specific fields like engineering or business. In fact, Musk actively advocates for teaching critical thinking, and specifically first principles thinking in secondary education. He believes it's not merely about learning facts for tests. It's about developing the fundamental ability to dissect problems, to question assumptions rigorously, and to reason independently from the ground up. He sees it as a crucial skill for future generations navigating a complex world.
So it's a skill for life, not just for building rockets.
Exactly. He argues that in this age of information overload, where we're just constantly bombarded with data, opinions, half-truth, prepackaged ideas from countless sources online and offline, people desperately need what he metaphorically calls a mental firewall.
A mental firewall, what does he mean by that?
He means the internal ability to filter out the noise, to distinguish between fundamental truths and mere analogies, assumptions, or opinions presented as facts, and thereby to build robust, independent reasoning. Without this kind of mental firewall, he suggests, we're too easily swayed by conventional wisdom, by peer pressure, by marketing, by superficial information. We end up accepting narratives without truly understanding their underlying principles or questioning their foundations.
So it's about resisting groupthink and misinformation.
Precisely. It's about building a strong, robust internal framework for understanding the world based on evidence and fundamental reasoning, rather than simply accepting external narratives or opinions at face value. This firewall allows you to process information critically, identify its core components, evaluate their validity, and then reassemble it into your own informed understanding.
That sounds incredibly relevant today.
Highly relevant. And his advice for young entrepreneurs, and really I think for anyone facing a significant challenge, is incredibly clear and consistent on this. He tells them, when you're faced with a problem or embarking on a new venture, do not just follow established practices. Don't simply look at what competitors are doing, or what the textbook says, or what the market research implies people want, and then just try to do it a little bit better or cheaper.
Resist the urge to just copy and paste.
Yes. Instead, he reinforces again and again, break down problems to their fundamental components and reason up to a solution. This means getting to the absolute essence. What is the core function you're trying to achieve? What is the undeniable physical, logical, or human truth at play here? And then, from that foundational understanding, build your solution incrementally, step by rigorous step, making sure each step follows logically from the fundamentals. And crucially, he stresses, do not rely on analogy or past experience as your primary guide.
Why not analogy? Isn't learning from the past useful?
Analogies can be helpful shortcuts for speed sometimes, he admits, but they also carry embedded within them all the assumptions and limitations of the original situation. Relying too heavily on analogy can stifle true innovation, he believes, and prevent truly novel breakthroughs from ever emerging because you're importing constraints that might not apply to your current problem.
So analogy limits you to variations on the past, while first principles opens up genuinely new possibilities.
That's the core idea. It's about being brave enough and rigorous enough to rebuild from scratch based on fundamental truths, rather than merely renovating an existing structure built on potentially flawed or outdated assumptions.
Okay, so let's bring this all together. What does this all mean for us right here, right now?
This deep dive has shown us how a seemingly simple, ancient idea, just going back to basics, identifying irreducible truths can be incredibly transformative. And not just for visionary billionaires building rockets or philosophers pondering existence, but potentially for anyone facing a problem, big or small, in their life or work. Absolutely. It's fundamentally about changing how you think about problems.
Yeah, shifting your mindset from just adapting existing solutions, which is often easier, to truly creating new ones from the ground up, which might lead to more elegant, efficient, or effective solutions in the long run. So I really encourage you, our listener, to think about an area in your own life or work where you could consciously try to apply this first principles mindset. Is there a long-standing habit you struggle to change? Maybe a business process at work that feels incredibly inefficient and just stuck in tradition? Or perhaps a personal goal that seems insurmountable because of how everyone else does it, or the conventional path seems blocked.
Instead of immediately looking at how others have approached it or how you've always done it yourself, try taking that step back. Question the givens. Break the problem down to its absolute fundamentals. What is the core objective here? What are the truly undeniable constraints, the real physical or logical limits? What is the simplest, most essential truth at the heart of it?
And then, from that blank slate, from those identified first principles, begin to consciously build your solution piece by piece. You might be genuinely surprised at the aha moments that pop up, the creative sparks that fly, and the truly novel solutions that can emerge from that kind of fundamental bottom-up thinking.
It's really about unlocking your own innate potential to innovate and create, rather than just follow established patterns.
So here's a final thought for you to mull over, a provocative closing question based on everything we've discussed. If everything you thought you knew about a problem, all the assumptions, the conventions, the best practices, was stripped away completely, what fundamental truths would remain? And, perhaps more importantly, what entirely new possibilities might emerge from that blank slate? Thanks for tuning in to this deep dive. If you enjoyed our content, don't forget to like, subscribe, and maybe turn on that notification bell.